Algebra 2, we've got a lesson on 10.6. It's a short lesson. We're today looking at inverse trigonometry. Inverse trigonometry to find angles. Okay, so far in this unit, we've used regular trigonometry, normal trigonometry, sine, cosine, and tangent to find sides. We've always found a side length. Today, though, we're going to move ahead and we're going to use inverse trigonometry so that we can find angles. So here's what's going on. Inverses undo. Look at example 1a. What undoes adding? Subtracting, right? That would undo that. What undoes squaring? No. Square roots, right? If you had squared and if someone said, hey, let's quickly undo that, take a square root. So the bigger question is, what undoes a function? The answer is the inverse function. Okay? The inverse function, guys, is really the undo button of the function. It will make the function go away. Just like if you wanted addition to go away, you'd subtract. If you want to get rid of a second power, a square, you'd take a square root. So you can think, so what undoes the sine of theta? Answer is inverse sine. Now look, on your calculator faceplate, you can see sine, cosine, and tangent. But if you look right above, you'll see sine -1, cosine -1, and tangent -1. Those are inverse trig functions. Okay. Listen, this is what we've got right here. The inverse function and the function cancel out. You just have an x left. Inverse sine and sine cancel out. You just have theta. Because an inverse is the undo button of the function. You want the function to go away, you have to take the inverse of it. So take a look at example 3 right now. If I want to just have theta, I want sine to go away, I can't divide by sine. Sine isn't a number. Sine is a function. So I need an undo button to make it go away. What do I have to do? I have to take inverse sine on the left. I'm going to have inverse sine applied on the right. That's still the basic premise. What you do to the left side, you do to the right side. Now, what you're going to see real simple is it becomes a calculator problem, but please check your calculator right now. You have to be on the right mode. And guys, if you're not set on degrees, every one of your problems will be wrong. Don't want that to happen for you. Again, it just takes a moment to check. Press mode, and you should see degree highlighted. The default position, though, is to be on radians. When you buy a calculator from the store, it's set on the radian mode. If that's what yours looks like, just put your cursor over degree, and then you have to hit enter. It's not going to engage until you hit enter. Also, what we've been doing, normally float is highlighted, but you can put your cursor over 1 to make sure you're rounding to 1 decimal place. So look, I'm going to just quit. I'm going to hit second mode here, and now we're going to be able to type in second sine, not the ordinary sine. Some kids were doing that in my other class. They're saying, hey, I'm not getting what you're getting. They didn't type in exactly what we had here. You want to see sine with that -1. Inverse sine of 1/2, you work that out. That's when you get 30 degrees. Okay? So that's primarily what we're going to be doing today. Real quickly, we're going to do 3 application problems. And the wonderful thing is, guys, you're still going back to this real important mnemonic of SOHCAHTOA. SOHCAHTOA is still going to be relied on for every lesson in this unit. And once you have that mnemonic, you'll know which trig function you need to work with. So help me out. Here is a triangle. We've got x. What would I call the 9 here? That would be opposite. It's directly across. What would I call the 13? That's your hypotenuse. Now, the way we're using SOHCAHTOA is you could see, well, I'm working with O, I'm working with H. Where do you see O and H? Right here with the first part of our mnemonic. That's the S for sine. And we've got the sine of x, and the order matters. You need opposite over hypotenuse. That opposite, that middle letter is your numerator every single time, right? The last letter is your denominator. That matters. If you flip that fraction, you're not going to get the right answer. But the bottom line is, I want to know what my angle is. I want to know what x is. And that means I want sine to go away. See, I just want to have x. So we've talked about how to do that. What should I do to both sides? Inverse sine. You're going to do inverse sine on the left. You're going to do inverse sine on the right. And guys, right now, all you got to do is just carefully type in second sine of 9 over 13, and then you get your answer. It's 43.8 degrees. 43.8 degrees, you are done. Guys, we've done a lot of problems in this unit already. I think you can see that these are shorter problems than some of the things we've been doing, right? Any questions so far? Okay, we're essentially doing the same thing for every one of these problems. It's just that very likely you'll have a different trig function. Let's go to this middle problem right here. Here's my x. What do I call the 43? Opposite. What do I call the 22? Adjacent, right? So from here, I've got opposite and I've got adjacent. And which trig function works with O and A? Tangent. So I'm going to write down tangent. I have tangent. So we've got tangent of x is equal to 43 all over 22. You got to follow that order. Guess what? You're going to have to get x alone. Here's the common theme. What are you going to do to both sides? Inverse. If you're finding an angle, you're going to find inverse. So you're going to go inverse tangent of 43 over 22. And guys, that's pretty much just button pushing at this point. All you got to do is type in second tangent. Number one mistake is for kids to not have inverse tangent typed in. They just type regular tangent. You'd get 62.9 degrees and you are done. Okay, we okay with that one? Last one. Here we go. Here's your x. Pardon me, this got jumbled up a little bit. Here's your x. What do we call this 13 down here? That's your adjacent side. What do we call the 15? Hypotenuse. So I've got A and I've got H. With A and H, which trig function are we looking at? Cosine. So we've got the cosine of x. That's equal to 13 over 15. That's your adjacent over your hypotenuse. Guess what? We're going to take inverse cosine of both sides to finish this. And guys, as we do that, we're going to just be done right here once we type that into the machine, right? So we go second cosine, 13 over 15, and 29.9. You know, these cancel out, and you've got 29.9 degrees. Okay? Any questions?